Nice Friday stream. Seeing if I can stay awake and focus before the weekend. That's the name of the game today. We'll see how it goes. I am going to work on my SVG library like I have been, and that's really all I've got going on at the moment. So let's head over to that directory. Oop. There we are. Let's split this up and get things going. There we go, ready to work. Okay, so yesterday I finished off with a function that let me convert SVG path horizontal and vertical lines into equivalent versions of line calls. So geometrically, these two sets of commands will draw the same path, but they end up having a different structure. So I already forget what commands to path string. Right, so this is not the same path as this one in terms of how, or in terms of what commands are written, but they are graphically identical. So that's, I have nothing to say about that. That's what I managed to get done. And now, what's a good next thing to work on? Let's see. So I have something ready for rotate path element here. It's not perfect. It might work. I have to check it though. That's the thing. Before I check, I think I would like to build in the scale function, fix that up, and fix up. I want to change this. I'm going to delete this color element thing, and I'm just going to make this function style instead. Yeah, that's fine. This is also not this is not at all what I need anymore. So I can delete that actually. Before I work on scale, I'm going to work on... Hey Mike, how's it going? Hope you're well today. Happy Friday to you too. I'm personally quite glad it's Friday. Looking forward to the weekend. Let's see here. How'd the stream go? Got caught up with work and couldn't drop in. Oh, no problem. The stream went well. It was a little quiet in terms of chat. There was a little bit of chat early on, but you know, that's okay too. I managed to work on, so the path DSL thing is getting close to done. I am just finishing up the translate, rotate, and scale transformations for path elements. I worked in particular on an algorithm that helps me convert horizontal and vertical line commands into regular line commands. So that was a pretty fun little thing to work on. Yeah, and other than that, just kind of kept plugging away at that, feeling pretty good. Feeling pretty good. So I don't know if that makes a. Let's see if maybe I can explain this just a little more clearly for a moment. So when you have the paths strings here, right? There's a list of commands you can use. In particular, what I'm talking sounds like it was pretty productive. Yeah, it was. Just to clarify a little bit, the L command is a line command, and you pass into it an X and a Y position. But to draw a line, you need 2 points, right? So every command in the SVG path language implicitly, it's as if you're drawing with a pen, and the previous command's end point is automatically the start point of your current command. So an L command implicitly has the starting point being your previously defined endpoint from the other command, and then your new point to go to. H and V are short form commands that let you say, from the previous command, move in this X direction only. Likewise with V, move in this Y direction only. The reason, presumably, that exists as in the spec is if you have a lot of straight lines, you can optimize the string size down significantly by removing redundant positional arguments like that. So positional arguments is the wrong thing to say. By removing coordinates, parts of the coordinates. Now, the reason that's a problem comes up when I do a rotate element path situation. So for example, if you consider the idea of rotating, where did it go? Well, I deleted it. So imagine you're given a horizontal line command and you're told to rotate it 45 degrees. If I'm going to bake in the positions of those new points, like I'm going to calculate the positions of the start point and end point after rotating, I can no longer call it, I can't draw it with a horizontal command drawing. So I have to have an algorithm that will run through my commands and convert any horizontal and vertical ones into line commands for the situation where I need to rotate out of the planar position. I hope that makes a little bit of sense. If I go look at my translate element here, I do have implementations for horizontal line and vertical line, because all I have to do is adjust the Y or X input and everything else can stay the same. But that is simply not true for a rotation calculation. You know, if you have position 0, 1 and you rotate it out of the plane, you need both X and Y coordinates, otherwise it's not the right point. That makes sense? Yeah, okay, good. Cool. So all I did here, I don't know, Mike, if you've ever used them, but I used an iterator. Actually, I'm pretty happy with how it turned out. There might be a more effective way to do it, but it worked reasonably well. I'll show you quickly what I did. Basically, if I look at this test command here, imagine I have this vertical line and this horizontal line. I can't fix that because I don't have any prior information. I need the X or Y position. So in order for you to convert things, you have to go sequentially through you have to go in order through the sequence, looking at each pair. And so you take the previous command and the current command, and in the situation where you have a line or an M or a move command or something that has coordinates as your previous command, and a horizontal or vertical line as the current command, only in that situation are you able to convert that V into, or H into an L. So since there might be entire chains of HV calls, you can only ever transform one at a time and then pass that new sequence into the same function and run it again. And the idea is you iterate through that until the whole list ends up being the same. So I just have a predicate that checks if there are in the whole sequence any vertical or horizontal lines. If there are not, you don't have to convert anything. This function converts a single pair of let's say, a line command followed by a V command. It converts it into 2 line commands. And then these two just wire it up in an iteration here. So the iterator just runs a function on an input, and then that function outputs a converted input of some kind. That result gets run again through the same function. So it's exactly what it sounds like. It iterates, and then iterations make an infinite sequence. That's a neat way to solve the problem of multiple and successive vertical horizontal lines. Yeah, I thought it was pretty clever. What I'm not certain of is if it's actually the most quote unquote optimal way, but I do know that it works, and at least for right now it's more than sufficient. So it's just fun too that iterators actually worked, which is nice. So this here is just, the iterator will it'll just create an infinite sequence. So what I need to do is just make a little bit of logic that will keep taking the iterations until the 2 iterations are exactly equal, which is my stopping condition, right? Once you know that the list and the next list you calculated are exactly the same, you can stop calculating altogether and just take that final result. So that's all that this is doing here. So I'm just iterating the convert first over the commands, and then you just check as soon as they're equal, boom, done, return that final result, and then you're good to go. So that's what I managed to get done yesterday. Pretty happy with that. Now today, if things go reasonably well, I just want to tweak a few things here and get even closer to a more complete implementation. So the things to do next are related to geometric computation here. That might be a bad name for this heading, but I couldn't think of anything else. So the things I want to calculate are the bounds. So an axis-aligned bounding box of a shape is exactly what it sounds like. A bounding box is a rectilinear shape perfectly up against the edges of a shape. And if it's axis aligned, it means you can get the width and the height from the x and y coordinates of the corners. Midpoint is a mistake in terms of naming on my part. So midpoint is I forget what it is. It's the average. Yeah, it's the average position of all the points that make up a shape. So it's actually the centroid. That's a more correct word to use here. Midpoint, as far as I understand, kind of only refers to the average position between 2 points. So the midpoint of a line is the exact middle. But a centroid is, this here is a centroid. And then these are midpoints here, right? So it's a little bit different, I guess you could say. Anyway, all that means is this is just labeled wrong. And here, I just need to make sure that this is actually going to be correct. So it's useful to get the I'm going to keep mixing it up from time to time. It's useful to get the centroid of 2D shapes, and different shapes will have slightly different ways of calculating it. For example, a circle and an ellipse, they have different properties. Oh, you know what? It turns out I used exactly the same implementation. Oh, that makes sense because calculating it based on the shape might be relatively straightforward, but the data structures that are used for different SVG shapes just have their data stored in different keys a little bit. So I sometimes might need to change the implementation. Not a big deal. I just have to do that. The only time that becomes more complicated is with things like path and polygon, where you have to actually calculate the averages based on a whole set of points. And in particular, a path might be even weirder because you can have curves in it. So if I only ever pull point data from the path, I could end up making bounding boxes and midpoints or centroids that are technically wrong. But I'm getting ahead of myself a little bit there. I think for most elements it's pretty trivial, and even for most paths it's pretty straightforward. So I might come up with a reasonable kind of compromise. But I use these functions in some of the transforms, so I have to make sure they at least return valid results for everything, including the path. So that's kind of what I'm poking around at today. Yeah, that's really all I've got. So may as well, already making mistakes here. May as well rename it, right? Since I know I want to be consistent with that. So text is an element that I don't have solutions for yet. So I basically, in every situation, just have a stub where I effectively end up treating text as a single point. And so when you write a text element in SVG, it's some starting point here, and then the text is above and to the right of that point. And so for the time being, I'm just transforming the position of the point, and for rotation, I'm using a rotation transform. It's just not, it breaks the logic I've used for setting everything else up. That's the only thing I don't love about it, but I need to be able to have it just in case it is being used in some shapes and stuff like that. Those are the kinds of things that it's like the last 5 to 10% functionality of the library that ends up being the stuff that's harder to make decisions about. But again, I get ahead of myself. So the other thing I have here right now, I have a call to the Forge library. I am going to replace that entirely. I don't want this library to have dependencies on my other prototype libraries. That wouldn't be easy for distribution. Pardon me. So instead, I have the centroid function here in the utilities that I can just use instead. It works. It just gets the arithmetic mean of all the given points, which is exactly the definition. The arithmetic mean position of all the points in a figure. So there it is. I should rename this, I think. There, centroid of points. The reason is because I am going to have a function centroid that works on not points, but on SVG elements. So I have to change the name. Here it's just going to be centroid of points PTS. Okay. These can stay the same. See here with circles and ellipses, there's some base properties in the shapes called center X and center Y. So all I need to do is pull that data. It's already calculated. For a line, it isn't. You have the start and end points of the line, so you can get the centroid. In this case, it is the midpoint. It's the same in that case. Path here is more complicated, and this is kind of the thing I have to pay attention to now. But before I get to that one, I am going to make sure all the other ones are fine. All they really have is a need to change this. I have to check string to points does work, right? I might not have that function defined. I don't remember. No. I thought I had that. Where was that? Oh yeah, this is it here, S to V. Function names are, I'm constantly mildly worried that I have bad names for functions. You know, because naming things is still hard for me. S to V. There, that's what I was looking for. So this is just helpful for, turns out that's not what I need, actually. Oh, no, okay, so that is correct, but that's not sufficient for splitting up a polygon path. Yeah, so I actually need to do this. I actually need to do map v this thing onto string/split this. Split the string that comes out of here with the spaces. I might rework this a little bit, but I think that should be fine actually. So basically what I've got here, let's just run it in the REPL here. People yell at me because I make my function names pretty verbose. You'll always have some people, some folks who think you're naming well and some who think you are. Best not to stress about it. I think that's probably good advice. So I understand. Oh, hey Lumi, how's it going? Hope you're doing well. I understand it being kind of smart to name things a little with a bit of verbose terminology. And then I run into the situation where I'm using the same function calls a lot. In particular, when you're doing CAD graphics and stuff like that, you use things like translate, rotate, and those things a lot. So if you could type TR and ROT, it just compacts a lot of the code and is faster and a little more fun to write it. But then you easily run into accidentally shadowing function calls in your let statements and stuff like that, because TR and ROT might be really simple short forms for other things as well. So you end up wanting things to not be too long, because then your code is massive and just looks like a wall of text. And if things are too short, you run out of, if you could only use single character variable names, you would only have 26 variables to work with. And then you'd have to start adding accents and using capitals separately, and it would be weird. It would just be messy, right? So there's this balance going on here. Anyway, blah, blah, blah. I shouldn't worry too much, I think, is the good moral of the story there. I hope you're doing well, Lumi, by the way. If your code doesn't read like a great American novel, then you're not really coding. Oh man, poor future maintainers, aka future me. I've said it before, and I'll say it again. I really love when I can delete code that I wrote. Keep that stuff short if you can. Lumi, good to hear you're doing well. That's nice. How am I doing? Oh, I'm doing great today, actually. You know, I happen to like Friday quite a bit because it means I could just look at my watch and say, oh, it's only a couple of hours, and I can give myself a nice long break over the weekend. I'm looking forward to that. I also am, I guess I'm just in a good mood in general, which is always nice, right? Nothing in particular, just feeling good today. I will say, so I'm working on another YouTube video. I made a YouTube video about making a Hiccup compiler clone. And I'm working on another one. And it's a bit of a far-fetched idea, but I managed to make... This is related to a game, Hades, that I've been playing. And I'm making this silly little randomized app that kind of, as you're playing the game, it rolls different body weight workout exercises you can do. The idea is you can connect the gameplay to a workout. So I'm just making, because I thought that was kind of a fun idea. I just wanted to make a little app isn't even the right word, just a little page that kind of captures that idea. You can't see it, but these are all specific workout names and stuff like that. And the whole idea is they roll it. Obviously I have to fix it yet. It's not finished, but these numbers are randomized for different difficulty and all that kind of stuff. So I'm in a good mood because I actually am happy with how this has turned out. It looks pretty cool in my opinion. And it actually works. The logic of doing it works. I actually tried it before already with the prototype, and yeah, so this is unrelated to the library I'm working on, the SVG library work. This is just a little side idea I had, and I'm just happy that it worked out okay. It fits the style and all that, so I guess that might be why I'm in a good mood, because it turned out like I had the idea in my head for how it would look, and I actually have it mostly there. All I need to do Yeah, can confirm, so I'm doing it. Not speedrun friendly. No, you're totally right about that. It is certainly not for speedrunning. The next thing to do with the rest of this is clean up the... I mean, just clean it up a little bit for appearance and add icons for the different exercise types. And if I want to be super serious about it, it would make sense to have a little demonstration for each of the exercises at the bottom of the page. The idea being that anyone who wants to use this could just go to the page, play a game, and just have this on another, like on their iPad or on their phone while they're going. So anyone can use it just from visiting the page. But if it's someone newer to different workouts, it might be good to have a little blurb and a little image explaining how to actually do the exercise. If I think about it further, it would make sense to have a little selection to turn on and off different exercises based on the equipment you have. But once again, I get ahead of myself. Point is, I've got a lot of good base work done here. The idea works. It's starting to look pretty cool, and it's going to be a fun video to make next. So that just makes me happy. And I'm happily moving forward with SVG-CLJ as well. It's coming together, and that is just great. Oh. So, not sure if any of you saw, there's I think it's called the State of Clojure survey. 2021 survey has been put out. I filled that out yesterday. Not sure if you guys care to do that sort of thing, but go for it if you haven't already, would be my suggestion. That's a non sequitur from what I was talking about before, but it popped into my head, so I figured I'd bring it up. Okay, where was I now? Oh, yes. So, this here, I need to change this because that's not actually the right call anymore. In fact, I have to do... Oh, that's right. This is what I was doing. I was checking the logic of this approach here. String split points. Oh, wait a second. I'm just going to put a test string in here, 0023. Split that string with the matching spaces, and then map S to V over that. It should give me a list of points. It does. Okay, that's what I wanted. Using that logic, I can put the same thing here. So polygon and polyline end up having the same centroids. Which, actually, now that I think about it, I'm wondering if that actually makes sense. Lumi, as for the short names thing, in my opinion, I prefer Clojure names to be longer. Typing those things can be worked around with auto-completion or typing shortcuts in the editor. If you want, Emacs has ways to replace words with shorter ones for presentation, etc. That way, you ensure all functions and names are intuitive. There are other languages more optimized for succinctness. You know, Lumi, that makes a lot of sense. The only counter I would have to what you suggest with, well, so auto-completion makes sense straight up. I haven't set it up in the context of org mode, right? Like I use org mode to write plain text notes here, but haven't figured out auto-completion for code blocks. But that's out of laziness, not out of impossibility. But as for typing shortcuts in the editor, that also makes sense, but I don't want it, if I imagine someone else using my library in the future, I don't want to force them to create their own editor shortcuts for my library to be useful, right? Not saying that's what you're suggesting either. You can use an indirect buffer. Okay, I'm going to have to look that one up. I'm not going to look into that right now. I'm going to add it to my notes at the end here for org mode autocomplete in code blocks. Look up indirect buffer. I'll get into that later. Thanks for the heads up there. I appreciate that. But yeah, so like for myself, I could have function names that are whatever, very explicit, they're longer, all that stuff, and then just kind of have a bunch of aliases in my own Emacs, which would work. It would make things look really smooth, but it seems maybe it's only a minor barrier and it's not actually a big deal. But if I were to have someone else use the same functionality, it might just bother people to have to install that themselves. That's not much of a counter argument or anything. It's just the thought that came into my head about that. But your points make a lot of sense. Clojure is not particularly optimized for really, really short names. So yeah, it makes sense. I feel as if I've naturally come to a pretty reasonable balance of it on my own anyway. Like it doesn't actually bug me that much. I run into it a lot in like if I have, let's say, some let statement and I want to do, if I need the width of something and then I also need the half width, right? What I would rather do is half width like that, right? So it is only really relevant in the short scope of the let statement, but I worry about stuff like that sometimes because that can also get a little confusing. But anyway, again, not complaining, just spewing my my brain's the thoughts from my brain out into the world. Okay, I was wondering briefly if the mathematical concept of centroid actually makes sense in a polyline, and I don't know, but I'm gonna just let it be the way it is right now. I think it's fine. I think it'll be equally intuitive. If you can compute the centroid of a polygon, then a user might say, well, if I take exactly the same set of points and specify those points to be a polyline, the centroid intuitively being the same position makes sense. So using the same implementation to calculate it seems reasonable here. I'm not too worried about that. I think it's totally fair to do it that way. And then text, I'm just going to leave it. Okay, so that leaves me here at path, where I have to figure a few things out now. So the first thing that comes to mind here is basically this. Let's do it this way. I just needlessly complicated my life there for a second. Oops. Here I do path centroid is its own little thing here. It's not necessarily too complicated, but I want to think through it carefully. I also realize here, declare centroid element here for a group tag. You do centroid of points into set map centroid over content. Group centroid. Then the interface for this whole thing is not called midpoint, I'm calling it centroid. And then all I have to do is change these calls to their proper names. And that should be good. Nothing else changes here. Oh, this does. Boom. Good. All right, that leaves me just to think about the path here. So paths get split into commands, and each command has slightly different meaning. The only commands that do not have point data are, or complete point data, I should say, are vertical and horizontal commands, but I have an algorithm that converts any of those into regular line commands so I can get the points from there. The first idea that comes to mind is the first idea for calculating path centroid is to get all point data from every command, map cat them together, and just run centroid of points on that list of points. So that's the first idea. That will work in almost every case. I have to back up a second and think if that's actually true. That will work in any case where I am basically drawing polygons with the path command. Where it could break down are paths that use Bezier curves and arcs, because wait a second, it might only be related to arcs. Convex hull of Bezier curves. The convex hull of Bezier curves might be fully defined by the control points. Yes, that's okay. This is what I was looking for here. The properties of the Bernstein polynomials ensure that all Bezier curves lie in the convex hull of their control points. Oh, but okay, so what I was thinking was, because the convex hull is guaranteed to be because the Bezier curve is guaranteed to be inside the convex hull of all of its control points, what I was about to assume was that the centroid of the convex hull would be an acceptable centroid of the curve itself. But I don't think that's actually true. It might be, but I'm not certain. And the reason I think that might not be true is just if you visually look at, if I had to guess where the centroid of this shape would be, I would put it about here where my cursor is. But if I had to guess where the centroid of just the curve is, I would kind of assume it was slightly beneath it. So they might be different, but that's not a rigorous check by any means. That's just a visual intuition, which could very well be wrong. Maybe let's just search centroid of Bezier curve. Maybe there is some, maybe there's something that can enlighten me here. Doesn't totally seem to be showing me what I want here. I could also come up with an algorithm to calculate the approximation, right? If I make a parametric equation for any given Bezier curve, I can sample the parametric thing at common intervals of the parameter t, and then that would make a approximate straight polyline of the curve, and then I could use centroid on that. And I wonder what will be better. But that seems not worth the trouble right now. So I think what I'll do in the meantime is go with my first idea here, and just leave notes for myself here. I don't know yet if the easy method will be accurate for paths that contain curves and arcs. It is possible that the centroid calculated by points/control points is not accurate. Ideas to keep in mind: parametric Bezier curve, sample t at regular interval to build a polyline approximating the curve, and calculate centroid from those points. What else? Oh yeah, what's the word I'm looking for? Tessellate? No. Yeah. Tessellate the whole path and get centroids of every triangle. Then centroid of centroids should be okay. Okay, so those are more complicated and annoying to do relative to this idea. So that's why I'm starting with the first idea. I will have to check that it actually ends up being useful. It might be way off base for complicated path forms, but in that situation, I might need to implement a lot of new functionality for more complex paths anyway. So since I know this should work for the common case of doing basic polygons, I'm going to start with that and explore more complex ideas later. So in order to do that, basically I just need to well, what's the right way to do it? I need a function that will take this list of commands and pull all of the point data out of it. So I can make a little def multi to handle all the unique command types. And it's very straight. It's actually a really easy def multi. It won't be hard at all. I'm just going to use this as the basis and go from there. Okay. Def multi. Yeah. Okay, so in this case, I don't even need to dispatch this way because this won't take any arguments. It'll just take, I think that'll work, right? If I'm passing the map in directly to command points, I can dispatch using the key command. That should be fine. And that means all I need to do here is destructure the map directly. All I need is the input. And I don't need to associate anything. I'm just getting data out. I think this is fine. I think that'll work. They're so easy to write, I may as well finish up the idea here. See if that makes sense. Line will also just take input. Once again, I'm forgetting the inputs are X and Y. So if I just take input, I get the point directly. Same with L. H and V, I know will be converted out of there, so I don't need to make a implementation for them other than maybe to return an error or something, but skip that idea for now. I don't know if that's a smart thing to do. Close will be nil, basically. Whoops. I think that's valid. I don't know. Okay, so there's command to points for curve. You know what? Let's stub them all quickly like this. So we've got curve, smooth curve. We'll have quadratic, smooth quadratic, and then the last one should be did I erase close by accident like a goof? I did. I am a little scattershot today. That's how I roll sometimes. Smooth quadratic. Okay. I'm pretty sure that's everything. So there's curve, Bezier curve, smooth Bezier curve here. Then quadratic Q and smooth quadratic is T. Yeah, okay, good. Should be good to go. And then arcs. Oh yeah. Last one, always the most complicated one. arc. Okay, so move in line, pretty simple. Curve, slightly different, ever so slightly, where all I need to do is, where to go? Right, so here, the points I need from it are, ooh, I just realized maybe I should do it like this. Wrap everything in a vector. So I get a vector of the points instead of just the points directly. We'll see. So here, for the curve command, it's going to be 6 numbers, and I'm just going to partition by 2, so then I get 3 points from that. So all I need to do there is map v vec over partition 2 of input. Is that going to work? Maybe I always forget this stuff. Partition 2, and let's imagine input is 0, 0, 1, 1, 2, 2. Oh, and map v that, so it's a vector, although it doesn't technically matter. Leave it for now. Right, so that is the curve. The S curve actually will be the same. Wait a second. I think I'm realizing that I can actually use this logic for almost every curve. The only one I cannot use it for is arc and the close path. So instead, what I should be able to do, and I'll find out if this is true soon, I can just convert this to default. So that handles all of this. The only ones it doesn't handle would be arc and close. So close is nil, which is nice and easy. And then arc has its own thing because it has different things that aren't geometric data. They're just flags. So the large arc flag and the sweep flag. So I also don't need the, oh wait, is that true? Once again, arcs actually throw off my game plan quite a bit. Boy, this is actually going to be a tricky one. I also don't need the as m in any of these. So this is definitely wrong. Whoops. But I am going to just do Take last is a thing, right? Take last, yeah. This is not implemented correctly yet. Just a stub returning wait, what are X and Y again? Are they the endpoints of the end position of the stroke? Yeah. Right, so that's right. So all I'm doing right now is cheating. Let's pop it into a vector. The vec of take last 2 of input in the vector. Does that work? Vec take last 2 of 3, 4. Yep. Good. Okay, so this is obviously not good. Arcs are going to be the hardest thing, just because of calculating correctly things like the bounding box and the center of an arc that could possibly have 4 different orientations at any given time, and then recalculating those parameters after you do something like a rotate or even a non-uniform scale. That can be kind of complicated. So that's why I say it's a challenge. The other things are challenging too, like Bezier curves and whatnot, but they're a little more straightforward in that they're only dependent on positional data. So that's just different again. Got to run for an appointment. If you don't get back, have a great weekend. Be safe. Yeah, Mike, you too. Hopefully your appointment's okay, and have a good weekend. Thanks for tuning in. I always appreciate it. All right, so enough chit chat about the problem with arcs. Let's see if what I came up with is actually going to even return valid data like I want it to. We'll have a little peek there. Centroid element doesn't exist because I haven't defined it yet. No namespace S. Oh, right, it's string split. Oops. Okay. What did I miss here? Oh, I didn't actually build this function yet. It's still not correct. Whoops. So command to points works. What I need to do here, given the element path, the props of a path will have, how did I do this now? Right, it'll be no, I'm thinking about it wrong now. Right here. This is what I'm looking for here. Path string to commands. D from props. Yeah. Of course. Commands. Takes a single path string, which is just the D key from the props map. Easy enough. Then points will just be command to points of map that, sorry, over all the commands. Map command to points over the commands to get the points, and then centroid of points of, oh yeah, this, can I map cat that? I think map cat should be fine. Well, let's see here. B is commands, right? If I do vertical horizontal to line commands of B, I get a modified path, which theoretically I should be able to run command to points. If I should be able to map cat that over VH to L of commands. Oh, if I don't typo it so badly. Let's see here. Hey, that did what I wanted it to. Good, good. That looks good. I actually wonder if I don't even need if I invent a command, I just want to check, I might not even need the close thing here. If I do command to points of this made up thing, it's going to be made up because it's going to be that. If I concat a full vector onto it with an empty vector, oh, okay. So I don't even need this. So at this point, I don't even need a multi-method here. I just have two conditions. I'll leave it as a multi-method, I think. That's fine. Because the other thought going through my head is if it's only two conditions, it might make sense to convert it to a regular function and just use a cond or something like that. But for the time being, I'll leave it because then you can add in your own defs or something like that. Or I can change my approach easily. But I do wonder about that. Like, at what point is it bad to use a def multi when there are only two there are only two dispatches anyway? Well, I'm going to leave it because I'm also not even sure that what I'm doing is going to make sense anyway. So it's probably good to just leave it, and then I can pull out more specific things if I need to. So I think that's fine. I think it's a reasonable choice to make right now. But using that logic, I can, I think, call this good. Oop, still not writing path string to commands. Ugh, geez, I'm not paying enough attention today. It's a bit of a it's just one of those Fridays, you know. All right, so map points comes from mapcat command points over all the commands. Makes sense to me. Then the centroid of points is just going to be, all you have to do is run the centroid of points on the points. Okay, there we go. That should work now. Okay, so centroid is done. Bounds is not yet, but I'll get there in a moment. What I need to do is check here. Okay, here I've got these calls to midpoint and stuff like that, which I don't need. So if I have a quick peek here, this I can convert to that. I think this needs to be reworked, but I'll check that this works reliably. I think it fails sometimes on 45, 90, 180, etc. Especially when used with path elements. Right, so this looks okay. Rotate point, where is that? It's up here, right, which I need to check, of course. You know, let me make this stand here because it's kind of related. These should probably also be moved to the utils, but that stuff can be moved later. I don't want to move too many things around too quickly because, you know, that's confusing. Okay. Here, get rid of the call to the forge part of the, I don't need that dependency, or I don't want it anyway. Centroid of points. You can assign multiple properties in a single assoc. And KVs. Let me see if I can get this working. A1. I don't know if I'm doing it correctly, but I'll find out soon. Oh, that's not quite right. It's just a straight list, I guess. Huh, wow. Thank you for that. That is much cleaner than this. I don't know why I didn't think to check that myself, but thank you. I appreciate the tip. That cleans that up quite a bit. Sweet. I could probably just do this. I don't know, that looks a little weird, but I'm okay with that. It's fine. I wonder if I could also just merge. I could just write this as a new map and just merge the maps, but I'm just gonna leave it because that should work. I think that's fine. I want to clean this up a little bit because I think I can actually simplify the calculation here. But in order for me to do that, I want to finish getting the library in a working state, then build some test cases, start doing the test cases, and then start improving the implementations there. Merging maps works. It is usually slower to execute. Oh, it is? Okay, fair enough. Fair enough. I mean, so no matter what, that pointer you gave where you can associate multiple key value pairs in a row or simultaneously is definitely a good one. That cleans that right up. Should be okay though. You know, that's just gonna be fine for now. Here, this is a polygon. This function I don't have anymore, so I just have to change the logic of this a little bit. It's not too hard. It's just map cat. Wait, let's make sure that that actually is going to work. I don't think. No. I'll just do this. Map vector to string. Then here, since that'll be a sequence of strings, you can just apply string to that. I would like to check that that's going to work the way I think. Zero, 0, 1, 1, 2, 2. Map v to s over that. Apply string to the result. That does work. Oh, I need to I have to do something like this. If I don't apply string here, right, then I get a nice sequence there. So if I instead do this, and then I do apply string to interpose spaces between those points, then I get the thing that I want there. Okay. Apply string to interpose space between the result of this. Yes, that gets me the right structure there. So that's the polygon. It looks like it should be okay. Here, string to points. Oh, I skipped over this. This is also not correct. I do need to do, to get the list of points, I actually need to do map string to vector of those points, which is exactly, I've done that before already. String to vector of the string. Oh, no, it's not quite done. I need to split it. Yep. So that's the points. Then the new points are those points, you do the rotation, then you convert it back into the string, and then put that back in the props. There. There's no difference here. There shouldn't be anyway. I don't know why I ended up naming these all differently, but that's a little weird to me, but okay. You know what? I'm gonna do this though, because better to be consistent in this case. Okay, here it's not midpoint, it is centroid. Let's change this to CX, CY here. I don't remember I don't remember where these come from. So I need a second to think about that. It isn't going to be too hard, but I just need to get it right. Shapes. Well, I have to figure out what I was thinking with that, but before I do that, I am gonna head to the washroom just for a minute. I will be back in just a couple minutes. It won't be too long. All right. What's going on here? Hey, Vakali. Always get your name wrong. One day I'll learn. How are you doing today? Hope you're well. I hope you're well. Anything new going on with you? How are you, bro? I'm doing well. I'm in a good mood right now. Feeling good today. Just working on my SVG library here, trying to get some good code going, you know. You're so-so? Oh, well, so-so is okay. At least it's, do you enjoy Fridays? I think most people enjoy Fridays, so I'm going to go out on a limb and say at least it's Friday. Thumbs up. That's good. Let's see here. Right. Just trying to remember what I was trying to do with an earlier implementation of this rotate transformation here. So I'm trying to recall. Let's go. Yeah, let's go. So I'm kind of, I don't know, maybe this seems a little boring to you, but it's important. Well, I think it's important. I think it's cool. I'm making SVG shapes functions for all kinds of stuff to be able to do nice drawings, right? You can use the library to make hiccup data structures like this, and then you can compile it using an HTML compiler into valid SVG blocks, right? So my library adds, or it is a kind of wrapper to let you quickly make shapes with transformations, rotations, and all that kind of stuff in a succinct way. And I'm just going through multi-methods that I've developed here, and making it a little bit cleaner for handling more complicated SVG shapes, in particular SVG path elements. So to calculate the rotation and translation of something like a rectangle is really easy. You just need to do the math on the 4 points and the rotation and translation. That's also pretty easy for circles, fairly easy for ellipses, and so on and so on. But path elements are the most complicated because they basically have a whole drawing language inside themselves. What do I mean by that? I just mean every path element, you can draw straight lines, you can draw arcs, you can draw Bezier curves, and you can combine them into pretty much an arbitrary shape that you want, and combine them with you can draw things with holes in them and stuff like that. That's all really great for drawing, but it means the implementation for rotation and translation is a little more complicated. So I've just been going through my prototype code and trying to clean it up and kind of package it up in a more sensible way so that I can open source the project and make it, in theory, useful for other people to use as well. So that's the struggle at the moment. But I say struggle only jokingly. It's going well and I'm excited about it. But that's why I have to sit here and read my old code and try to think, well, okay, what did I even do? What was I trying to approach here? So that's what's going on with me. In particular here, I'm having a quick look at rotate element for rectangles. And I forget what this, or where I define this function. So if I go back to the prototype, I should be able to find that function somewhere. I believe it's a string helper function. So string to transform map is what I was going for there. Ooh. Here, this is what I had. And I'm wondering if I should just simplify this out a little bit. You know, might be smart to iron out that logic a little bit. Okay. So what I've done, this here, get from props, the key transform. If it exists, get that value. If it does not exist, get rotate 0, 0, 0. Okay. That's fairly straightforward. It's not too crazy. String to transform key value. Okay, so I did have some logic behind this. It might actually be smart to keep it back in there and just make the function names a little clearer. Okay, so here's what I'm gonna do. I'm gonna just put it back in, but I'm gonna make sure it's in a section that makes sense, and put a little note to myself about what's going on so that I don't lose track of it again. I also think I'm gonna combine this. I'm gonna move that blurb up here, get rid of this header. So now transforms computations. So transforms, let's here. So computations refer to calculatable properties of SVG elements. They are bounds and centroid. Yeah. Transforms, translate, rotate, and scale. Local first transformation. Groups must have their centroid calculated. Internally, this means that the group's centroid is treated as the temporary global centroid and all objects are globally rotated about that temp origin. This has the appearance of a group rotating locally, which is the intended outcome. Okay, so that's good there, but before I forget, I was going to check on this little chunk here. So utilities, I am going to put these right in the utilities here. So let's have a little copy paste here. So transform key value to string just means given a key value, turn the key into a symbol, apply list of v, string kv. Apply list to 0, 0, 0. Oh. Huh. I don't know. That's seems a bit one step too clever. Not sure if I love that, but let's do this instead then. Symbol K. Here, apply list to V. If I'm gonna be clever like that, I should just do that. These should be here. This utilities thing, I just should have vector math helpers, arithmetic, not math, for the lazy man. Simple calcs. And now here we've got some string manipulation, some string transformation tools. Yeah, that seems good to me. Okay, so this is fine. Right, so using this here, if I run this with transform kv to string, right, that should, if I do first off of this, if I do rotate 0, 50 degrees and 0 degrees around z. Oh, there's no z, it's just x, y. Rotate 0, 50. Perfect. Okay, so that does work the way I kind of expect it to. That would actually also work with translate. Perfect. Okay, not bad. And then the inverse of that, string to transform key value. Oh, which I haven't defined yet. String split. Nope. Oh, I should oh, there's a read string call in here. Not sure if I'm a fan of that one. Oh, I use read string a few times. It's okay. It's gonna have to be. That does mean, okay, I've got read string here for the Clojure script side. We're good with that, so read string is okay to use. Probably clean these functions up a little bit, I think, but let's just check that they work okay. So if I do string to transform map, with a string rotate 020. That works. And if I do translate 1010, okay, so here I have an issue. Well, that's weird. Okay, so that's not particularly robust. Yeah, that needs fixing for sure. There we go. To do fix in utils string to transform map and related functions. There we go. Okay. So I know I need to fix that, but I also know that it will work here in the rotate situation. So let's go no namespace F. You're right about that. Where did I miss that? Okay, let's have a peekarino here. Here it is. I don't know if there's you know what, I won't add any more of these in until I know I need them. That's probably the smart thing to do. Okay, there we go. So now let's check this again. Let's give that a shot. Okay, we have rotate element working there. Does rotate element for path. I still have a midpoint call in here, so let's find that one and get rid of it. This is, you know what, I should just delete that outright. I should also go here and just delete it from here as well. Oops, there we go. Just realizing what time it is. I get wrapped up in my own code, which is not bad, but then I always like almost wake up and don't notice what time it is, you know? Really, that's kind of a good problem to have sometimes, you know? All right. I've got a little bit of time that I can work on yet. Probably another half hour at least, so I can keep focusing for a bit. I like that. I always enjoy that. Right, so somewhere in the depths of these functions, I missed a call to midpoint, which is now called centroid. Not a big deal. It just needs to change. That is all. And that's right here, centroid. Beautiful. Using that, I might be able to, yeah, sweet. And now, centroid of the bounds of that. Global center. And then this is center if that you run centroid of points on the bounds of CH. Otherwise you just run centroid on CH directly. Then you transform center with rotate point, call V plus the global center E star okay, that looks good. Symbol bounds. Okay, good. So we're at a point where I need to define bounds. But before I do that, let me just clean up the translate because I realized I didn't do that yet. Let's also save this just to be safe, you know. Okay. Here we go. String to points doesn't exist. So here I have to do something different, and that new different thing is really easy. I'm going to use this as a reference. It's not hard, but just pay attention to it as a reference, you know. Okay, it should be okay. All right, translate element polygon. Here we are. Paste in this reference. Comment it so I don't get too confused. Okay, so I shouldn't need the centroid. I do need the points, which is just going to be this, right? Same thing. What am I doing here? From points props, I'm splitting the props on spaces. Oh, I forgot to I think that's fine. Yeah, let's call it okay for now. Then X points is just map partial v plus onto points. Then new props is just associate. I don't even need this line. I could just do this. Oh, this is also not complete yet. You know what? Let's do this. Take the points and thread it through map partial v plus xy. And now here I need to, oh wait a second, I'm making it more complicated than it needs to be. Okay, that can be the X points just fine. Now new props here is this whole thing. Associate into props at the points key, apply string to interpose spaces between X points. Right. Oh, this is why I'm flip-flopping with my ideas here, unfortunately. Let's do points after all. Okay. Map that function onto points and then map v to s. There we go, that's what I needed. Onto X points. That should work. Let's make sure it's closed properly here. Let that, there's that, and then polyline can be exactly the same. Very nice. Okay, now get rid of this reference. Okay, I think that's everything. Uh-oh. That's annoying. I must have typoed something. Let's just go figure out where it is. Oh, here we are. Oh, what did I miss? Interpose that. Apply string. Soch that. There we go. There we go. That does mean Polyline probably had it wrong too, right? Yep. Polyline, rectangle, midpoint, centroid, please. There we are. Thing of beauty, that. Let's change this to center X, center Y. Boom. Okay, translate. The elements are done. The path element, let's just check that that works. Ooh, I have a typo. Where did that end up? There we go. Okay, that's good there. Group translate. Let's see if it works. It does. Yeah. Let's build the interface. Ooh. Unable to resolve translate string. Oh, this is old and can be deleted. Sweet. Love it. All right, translate seems to be done. Let's triple check rotate. Rotate element path. Good. Group rotate. Oh, there's a problem. Bounds, like I said, that's sensible. And rotate string. Ah, another old function to delete. I love it. I love to see it. All right, that is looking good. Now we move to bounds, where we can get things closer and closer to complete. All right, points to bounds, very easy. Bounds element. Okay. Let's go. Circle. That's a little weird to me. Oh, right. Oops. Oh. So what I did here was maybe a bit of a bad idea. Yeah, I'll have to check that one. But okay, so it goes for now. Path, bounds, element, path. The tricky one. Maybe. Bounds, element, path. Okay, before I check out path, let's finish these other ones. Ellipse is fine-ish for now. Line was good. Polygon, let's check. Again, this points thing is wrong, so let's do myself the favor. Translate element, polygon, zip, copy. Oops, there we go. Same exact implementation for polyline. Let's have a look here. Rectangle, same. Nice. Text, same. Sweet. All right, so here for bounds element of path, you know what? It's almost exactly the same idea as the centroid calculation. So if I do centroid, path centroid, actually I should now do centroid element path, boom. Okay. Group bounds, I'm not there yet. Path, here we are. Right, so let commands be that. Yeah, and instead of centroid of points, I'm just doing points to bounds of points. Yeah, that's really easy. Sweet, basically free. And it seems to work anyway. All right, that's nice. And now let's check if group is gonna work. Oh, unable to resolve. Oh, declare bounds, of course, need to do that. Now the interface for bounds works. Okay, it kind of looks like I've got everything worked out here. I might be speaking too soon, but things are moving in that direction of completeness, which I'm happy with. Let's do group rotate. Hey. All right, so centroid and bounds are now defined. Where's M? I changed the name of things so M doesn't exist anymore. M right here. Here it is. It should be center. Yes. That's the group rotate. Now let's build the interface. Yes. All right. Now we're cooking. Now let's see what mess scales have here. This I don't know if is true anymore. Doesn't seem to work correctly in all cases. For example, scaling something down and translating a group containing it will shift it, which is undesired behavior, to say the least. Scale should be baked into all dimensions, just like other transforms where possible. Right, so scale is what? Scale's tricky because you're allowed to do non-uniform scaling, technically, which can lead to issues. Let me think about it. All right, I'm almost done. Just have to poke around in the scale implementation, which I'm not happy to do because it's kind of a pain in the butt. But we'll push through. You know what? Actually, now that I think about it, I wonder if scale doesn't work because I've never fully or properly implemented it, actually. Let's see here. Let's just go try to sort it out anyway, huh? Okay, so there's something wrong here. Bounding box center 2D. Oh. What was I trying to do here? Wait, why don't I just do... Okay. Let's add this to the to-do here. Admin to-do. To-do. Re-implement scale element. Re-implement scale transform. Seems incomplete already as is. Okay, there we go. But let's just have a quick peek at it anyway, get it kind of up and running. I don't use scale that much anyway, so that's why it's kind of remained a little bit untested, but it will be important to have as a tool when I release it. So I do need to give it proper care. For sure. For sure, for sure. For sure, for sure. But here we go. Where was I now? Right, so here, I don't need this. I just can use centroid of k props like that to get the center of the line. Yep, that's pretty easy. Scale element path. What time is it now? Oh, 4:30. Almost time for me to go. Got another 16-ish minutes. 17. Okay. Oop. Right, let's go. Grab the trusty translate polygon as a reference. Let's get this working halfway, or let's get it working. So points is this business. Good. Center is just gonna be centroid on K props. Easy peasy. This is not new points, it's going to be X points, and it's going to be thread last points through a few transforms, which are map partial scale point from center SX SY and then map it back into V to string sequence like that. That's that. And then this ends up being the same. That should work. Oop. There we go. Polygon and polyline should work. Rectangle should work. Text and G are kinda working. And then here, this won't work. It almost did, but it doesn't. So here I do need to have another peek at my translate just to keep things clean and easy. let's do this. This is SX, SY, scale element path, commands is that, points, oh, no, we do this. X commands is scale path command, XY commands. Okay, associate that there. Okay, so now scale path command is the thing I need to work on. And that is going to be kind of like this, right? Oh boy. Let's do def multi. Just start going from this as a base. Oops. Scale path command. Scale path command. There we go. Here you dispatch on command. And then here you've got SX, SY, and then the keys and input and all that junk. It's not junk, but it's all there. Okay, so I actually need to do I need the centroid of this. K props, not L props, please. And I will move that here. So using center, you can scale the command with center and XY. And then I can call, you know what, should I call it default? Not quite. Actually, I should. So here, centroid and bounds. Yeah. Okay. All right, we're getting somewhere, kind of. Okay, so here in this there we go, keys, input. Okay, that should work. Then here, let points be map v vec partition to input. Yeah, and then all of those points become transformed x points by the function, which is up here, scale point from center, the center point, the scale, and then x and y. Yeah. This transformation is basically correct. Minus, of course, this here. Actually, what you do is map cat this. Then this as m. Then you assoc into m input x points. Let's see if that makes sense. It does not. Scale path command there. Right, so that's the default. And the only other one that matters at the moment is arc, but that's going to be all messed up anyway. So for now, I kind of don't want to, well, let's just do it like this. Let's get rid of that. Arc. This is wrong. Just a stub to get moving a bit. So the points in this case would be just take last 2 of input. But I have to wrap it in a list just to keep that part simple. And then everything else is the same. So that is kind of scale, kind of working a little bit. I don't expect it to work fully properly, but hey, we've got a beginning point here to go with the rest of everything. So that all should work. It seems to, for now. Okay, scale element path. Let's check the interface. Still some issues there. Scale string. This is old. Okay. Things are looking okay. I don't expect it to all be finished yet though. So let's look at B. Let's do VH to L of B. Now let's do commands to path string of VH to L of B. Now let's do path of all that. Now let's try rotate 45 degrees this path and see if it breaks on me. Ah, it does. Okay. Well, now is exactly the time to start doing proper testing, so that's good. We're at a point where we've got the functions able to compile, and now it's a matter of starting to build out some testing and getting it actually working the way it was before, reliably, and that should be fun. That should be a good... Oh, excuse me. That should be a good thing to start working on. Okay, but actually, I should get going, but before I do, it would be fun to just try and wrap my head around this one a little bit. So I have a valid path. Why is it not working? Because if I do rotate 45 circle, that works. So does rectangle. Nope. Ah, interesting. Okay, so I made a mistake somewhere. Isn't that fun? What's the difference between a rectangle and a circle? I'm not sure yet. Well, okay then. Well, there we go. I've got a few things to work on now. Maybe it's the centroid. Here we go, down the rabbit hole a little bit. Centroid element. Let's do centroid element. Okay, that works. So centroid interface is broken. Yeah. Okay, well, I'm not going to get into this right now. I am going to call it for the night. Centroid, bounds, translate, rotate, impulse ready for testing and further bug fixing. Scale implementation needs rework. Also, elements like text and arcs in path LMs are not handled yet. These need thorough consideration for robust solutions that don't exist. I have no idea what to do with them currently. There. Get status, get push. Okay, you know what? I am happy with that amount of work for the day, and I am happy to go take a break now. Friday is a good day to relax. So thanks everyone for tuning in. I always appreciate that. Thanks for chatting for a bit, those who did. If you're tuned in on another platform or at another time, I appreciate that too, by the way. It's always, if you're interested in helping things grow and continue, it's always helpful to share this around to people who might enjoy watching programming, might enjoy Clojure or Lisp languages in general, and who also enjoy design. So consider sharing things around. That would be really helpful. Regardless of what you decide to do, I hope you have a good weekend. I hope your projects go well, and I hope things are well with you. Stay safe, stay healthy. That's all I've got. I'm going to get going. Have a good one.